I'm going to do 76 and 77 together because I want to show you how these differ. You show that things are linearly dependent differently from how you show they're linearly independent. So 76 will go here. 77 will go here. I encourage you now to pause and read the definition of linearly independent, linearly dependent. But it comes down to, let's suppose that we have coefficients such that this is true. And same thing, we're going to do the same thing over here. So 0, 0 is always over here, and you always have coefficients. To show it's linearly independent, we're going to have to show that A and B have to be 0. There's no other choice. For here, to show they're linearly dependent, we're just going to show that some pair exists. And you can almost do this by inspection. You can just say, I'm going to let A be negative 2 plus B is going to be 1. So that's a setup. Actually, I'm not continuing on there. So I'm just going to start with this and show that this is equal to negative 2, negative 4, plus 1, 2, 4. That's equal to negative 2 plus 2, negative 4 plus 4. That's equal to 0, 0. So 1, 2, and 2, 4 are, I'll be lazy and write LD for linearly independent, or linearly dependent. Why? Because I can find two numbers, they happen to be negative 1 and, or negative 2 and 1, where not all of them are 0. So if I had negative 2 and 0, that would mean linearly dependent. If I had 5 and 12, linearly dependent. If they both have to be 0 in order for this to be true, then it's linearly independent. Note that 0 and 0 work here. If I do 0 times this plus 0 times that, I do get 0, 0, but that doesn't tell me anything. That's always going to be true. That's boring. So if it's linearly dependent, I can find some numbers. Here, I won't be able to find the numbers. So I'm just going to continue on and say, well, this is A, comma 2A plus 2B, comma 3B. And that's, I'm going to assume that it's equal to 0, 0 here. Here, I don't assume that this is equal to 0, 0. I show it's equal to 0, 0 because these are non-zero. Now I'm going to start with something. These could be anything. I'm going to conclude that they have to be 0, 0. So A plus 2B, 2A plus 3B equals 0, 0. Well, this gives me two equations. The first component is A plus 2B is equal to that 0. And the second component is 2A plus 3B is equal to this 0 here. Well, what I can do is I can say that, oh, A is equal to negative 2B from the first equation. Now I can plug that in here. 2A, but I know that A is equal to negative 2B plus 3B is equal to 0. Negative 4B is plus 3B is equal to 0. So I get negative B is equal to 0. So I get that B has to equal 0. This is good because I'm trying to show that they're linearly independent. I need to show that both A and B have to be 0. But I'm not done because it could be at this moment that A is not equal to 0. If A could be anything that is not equal to 0, even if B is 0, it would be linearly dependent. But I know that A is equal to negative 2B, which is equals negative 2 times 0 equals 0. So since A and B must be 0, 1, 2, and 2, 3 are linearly independent. So this is how you show that something is linearly dependent. You just find some numbers that work and plug them in and show that you get 0, 0. Some of them can be 0, not all of them can be 0. And over here you have to do some algebra to show that no matter what A and B are, the only way that works is if A and B are 0. So you start off thinking that A and B could be anything, but then narrows down and you figure out, oh, B has to be 0, oh, A has to be 0. Those are the only options. That is all.